Hello guys, it's the tutor, and in this video I'm going to explain to you the product rule, when to apply it and how to apply it, as well as go through some examples with you. So the product rule is when two functions are multiplied. So we're going to say f of x is a function of two functions being multiplied by each other. So here you can see, let's just say this is h of x. So h of x is equal to f of x times g of x, and you want the derivative of it. So what you're going to have to do is you're going to take the derivative of the first function, so for example f of x, and multiply it just by the base function g of x, right? And then after, you're going to now take the derivative of the second function, so being g of x, and you're going to multiply it by the base function of f of x. And similarly, you can carry this on for however many terms. So if h of x was a function of three functions, so f of x times g of x times y of x, then you would alternate. So it would be f prime of x times g of x times y of x plus g prime of x times f of x times y of x plus y prime of x times g of x times f of x. So you would use this when this is the best time to use it, but sometimes it's easier to just use the power rule by expanding, and I'll show you what I mean. So here's the first example. So let's identify which one's f of x and which one's g of x. It really doesn't matter which one's what. So we'll say x squared is f of x, and we'll say the polynomial here is g of x. So then f prime of x, as we know, is just this, right? So it's just going to be f prime of x is equal to the derivative of this, of x squared, so 2x, times g of x, so 3x squared plus 3x plus 6. And then we're going to add, as we can see it's an add the base function f of x, so x squared, times the derivative of the second function. So 3x squared is going to be 6x plus 3 plus 0, right? That's our function. So now you could simplify this if you wanted to. You could just multiply it out, but there is no point. You could just, yeah, there's no point in factoring. So I would just leave it there. Next one. So this is what I meant. It is easier for you to just multiply this in. So if you just multiply it in, it'll just be x to the 5, right? And then derivative of that is just going to be 5x to the 4. Or you could do product rule if you want it to be difficult. So it'll just be 2x times x cubed plus x squared times 3x squared. So did I do that right? Yeah, I did that right. So, and then just to prove it to you, this would just be 2x to the 4 plus 3x to the 4. Which would just give you 5x to the 4. Same answer. Either way, I would do the product rule. And I'll tell you why the product rule is significant towards the end. So here, this is actually one of the reasons why it's important to use the product rule. So as you see, you have a very big polynomial, right? It's hard to expand it. It's not as easy to expand it like this one was, right? It's not as easy to expand it like that one. So you'd spend more time expanding than you would do taking the derivative. So that's not really worth it. And you can make a lot of mistakes. So let's do the product rule. This is f of x. This is g of x. All right, so what's the derivative of this one? It's going to be 0 plus 3 plus 6x minus 9x squared times, now we're going to just bring this down, 3 minus 3x minus x squared plus 2x squared plus 2x to the 4. Right, and then plus, let me move this so we don't get it confused. Plus It's now we're just going to bring this function, just put it here, because it's, remember, it was f prime of x times g of x plus g prime of x times f of x. So negative 3 plus 3x plus 3x squared minus 3x cubed times derivative of this one. So it's just going to be 0, derivative of 3 is 0, derivative of negative 3x is going to be minus 3, derivative of minus x squared is going to be minus 2x, derivative of 3x squared is going to be plus 6x, derivative of 2x to the 4 is just going to be 8x to the 3, right? Now let's see if we can do some easy simplification to see if we can take anything out together. Doesn't seem like we can. You could always multiply in and then collect your like terms, but unless your teacher specifically asks you to do that, don't do it, because it will waste your time and there's room for error, right? Now let's do one of these ones. F prime of x. Okay, this one's easier. This one, again, if you wanted to multiply out using a FOIL method or whatever method you use, it's going to be a long process with a lot of room for error. So there's no point. You can just do the product rule. So this one we'll say, let's switch it around. I usually do f of x first. It really doesn't matter. So let's just say this one is g of x. This one is f of x, right? And I usually did f prime of x times g of x plus g prime of x times f of x. So here you'll see that it's flipped and it does not make a difference. You can do it both ways and you can subtract and you'll just end up with a sum of 0, meaning they're the exact same thing. So let's do f of x first here. So it's going to be 0 minus 3, because the derivative of 2 is 0, derivative of negative 3x is negative 3, derivative of 3x squared is going to be plus 6x. Then you're multiplying it by the base, 3x plus x squared plus 3x cubed. I call it the base because it's not taking the derivative of, so it's just a base function. That's what I mean by base. So let's just be clear. This is our f prime of x. This is our g of x, right? Now we got to do g prime of x. So derivative of 3x is 3. Derivative of x squared is 2x. Derivative of 3x cubed is 9x squared. Multiplied by the f of x, 2 minus 3x plus 3x squared. Right, that's your derivative function. Okay. So now here, I could multiply this in, right? Okay, that'll make my job easier. But I'm going to not to show you how to apply the product rule if it's a function of 3 or more, if you know what I mean. So if you have to, this here you're applying product rule 3 times basically, right? So let's let me write, actually, let's say this is f of x, this is g of x, this is h of x. Okay, and we won't say this is f of x because we already used that. We'll say this is L of x. Right, okay. So now the derivative function of L of x will be f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. So as you can see, the derivative just move it 1 over. So multiply it by the next derivative. So let's do that here. So derivative of this, 2x plus 0, right? Derivative of x squared is 2x, derivative of 3 is 0. Now multiply it by everything else. Plus 3. Okay, now the next term. Now derivative of g of x. So we're going to write our f of x first. X squared plus 3. Derivative of x squared is 2x. Then multiply by h of x. X cubed plus x squared plus 3. Now, next term, we have to write the first two. So it's going to be x squared plus 3 times x squared. Derivative of h of x is going to be the derivative of x cubed, which is just going to be 3x squared plus 2x, which is the derivative of x squared, plus 0. And that is going to be your derivative for a function that is a function of three different functions. So like it is here, f of x, g of x, h of x. Now, this example right here, I'm going to highlight it in red. This is the best time to use something like the product rule, or this one. Even this one, because it's just going to be, I would multiply in, for example, the x squared and the x squared plus 3 first, and then I would do product rule. But the product rule, it really shows its power when you have no other option. For example, if you're doing something like, if you're, for example, doing like sine x times x squared, then you're forced to use product rule, right? If you're doing something like that, you haven't learned the derivatives of sine x yet, maybe, but once you do, you'll understand why. It's because you cannot use the power rule on something like sine x, so you have to use the product rule to break it up. That's the video. If you have any questions, please leave them in the comments. I'll answer them, and have a great day.